Welcome to JSworld. I'm Rob Richardson. Today we're going to talk about containerized deployments for your SPA and API. The code and slides for this talk are online right now. Head out to robrich.org, click on presentations right here at the top, and you can find containerized deployment for your SPA and API, both the slides and the code. Here's the code up on GitHub. While you're here at robrich.org, click on About Me and you'll get to some of the content that I've done recently. I'm a Microsoft MVP. I'm a friend of Redgate. AZ GiveCamp is a lot of fun. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp in your area, hit me up by email or on Twitter, and let's get philanthropy installed in your area as well. Some of the other things that I've done, I worked on the Gulp project in version 2 and version 3. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode, they read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame. Let's dig into containerized deployments for your SPA and API. Now as we dig into this, we may look at a SPA and API and start to get a feel for how each piece works. Now, as we have SPAs and APIs, we get this elegant separation of concern. The SPA focuses on a really good user experience. It's a thick client in the browser. And the API is JSON services, or maybe GraphQL, or XML, or gRPC. This separation allows us to focus on each piece individually. But then, as we bring them together, well, we have that separation to give us operational efficiency. We can scale each piece separately, but now we have the complexity of trying to glue them together. So let's dig into it. How do we deploy both pieces? Well, let's deploy them with Docker. Now, outside of production, in development, we'll probably build out a system kind of like this, where we have a Webpack dev server, either in our Angular, React, or Vue app, and that Webpack dev server will forward off API requests off to our server. Our browser will hit the SPA for everything. Our SPA will hit the API for those requests. Now in development, this works great. But as we move to production, well, now what? I've built some applications, and if we had more time, I would live build them for us. But I've done a .NET new MVC and built up a .NET API. Similarly, I went in and said, Vue create my app, and picked the options that I wanted for my API. And I've got that code here. Here inside Zero CLIs, we can see both the .NET API and our backend controller. In this case, this gives us some fake weather data. We also have a Vue app, which is pretty much identical to the way that we built it from the CLI. The only difference is I added one more control, this weather forecast control. Now this weather forecast control will go grab all the data from the API and render it on the desktop. So we're going to go call into /API/weather forecast, get that data. If it errors, we'll grab the exception and we'll display that content, either looping through the weather data or showing the exception. Outside this project is identical to a regular SPA app made from the CLI. Okay, so now how do we host this? Well, to start off, we'll need to create Dockerfiles. If we had more time, I would live code these Dockerfiles. But let's take a look inside the Dockerfiles for each project. We'll start out here with this .NET Dockerfile. And our goal is to .NET build, .NET test, and .NET publish this content. Now we will have a multi-stage build here so that we can have our production runtime as lean and lightweight as possible. This doesn't include our source code. It doesn't include our build tools. We're just going to publish this content into the dist folder. And then here, we will copy that dist folder into place in our new image. But we're not copying it from our host machine. We're copying it from build because we've named this stage as build. We have our multi-stage build that will do, for the most part, the build server pieces and then the production runtime pieces. In the front end, we have a similar Docker file where we can dig into building out that code. Now, we'll start from node alpine, we'll do an npm install, and then we'll npm run build. Now, similarly to how we did it in our backend API, we have a multi-stage build. Now, in this case, we could create a new node container, but, well, they're static files now, and we know how to host static files. Let's do that with Nginx. Now, here I've copied in an Nginx config that just says, if you ask for anything that doesn't exist, send back the index.html. That way, the client-side SPA can boot, and it can dig into all the things. So then I copy all my content into user share Nginx HTML, all of the content that was built here in this build container. And now we have 2 containers. That's perfect. So now how do we host them? Well, that's where we get into some interesting things. Should we host them as 1 container or 2? Should we host them on 1 domain or 2 domains? A domain and a subdomain, maybe www.example and api.example.com. Well, these aren't mutually exclusive decisions. We can host 2 containers on a single domain, we can host 1 container on a single domain, or we can host 2 containers on 2 different domains. Let's dig in and look at each solution. As we dig in, we'll probably ask ourselves, well, which one should I choose? And it definitely depends. Rather, let's look at it and say, when should I choose each one? When is this the correct solution for me? Compare that to your business needs and pick the solution that best matches your needs. 1 container on 1 domain, 2 containers on 1 domain, or 2 containers on 2 domains. Let's dig in. So we start off with just the regular containers. And if I just have my regular containers, I can start each of them and I can do some interesting things. Let's run our backend container. We'll run that on port 5000. And then let's also run our front-end container. We'll run that on port 3000. Now, it is hosting inside Nginx, and Nginx is listing on port 80. So we're going to proxy through the Docker router from port 3000 on our local machine to port 80 inside the container. Okay, so now let's go there. Let's go to localhost 5000/API/weather forecast, and we can see that we've got our weather forecast data ready to go. Now let's go to localhost 3000 to our SPA. Ooh, let's pull up the F12 developer tools. We got an exception. Let's refresh this and see what happens. Okay, so we got our main page, and then we went to go load our weather forecast data, and we loaded it on localhost 3000/API/weather forecast, which it obviously doesn't exist on port 3000. It exists on port 5000. These 2 containers can't work in isolation because, well, now this is cross-domain. And so we got an exception and we weren't able to load our weather data. Okay, let's stop both of these containers. Docker container rm-f. We'll stop this first one. And we'll also stop the second one. 1092. And let's take a look then at how we can build up strategies for being able to run these 2 containers together. So first up, let's look at 1 container, 1 domain. Now, in this scenario, our browser will come through the internet to 1 container that includes both our SPA and our API. The SPA will be hosted inside the API, much like any other static files would be hosted in a website. Maybe we put these in the public folder, or in the case of the .NET API, inside www.root. So how do we pull this off? The browser connects to the internet to that SPA, and we'll need to put the a static file hosting into that spa's public folder. So let's come in here to the code and take a look at that. Here in this one container, one domain, we see that we have one big Docker file. We don't have a Docker file in each project anymore. This one big Docker file will accomplish both sides. We'll build only one container, so one Docker file is sufficient. We'll start off building the .NET container. Now, this does exactly the same things that we did when we built the .NET container in our original example. Then we'll also grab our Vue content and install that into place. We'll run npm run build, and now we have a dist folder with our backend and a build folder with our frontend. As we construct this Docker file, this third piece will run the backend, so we're here in an ASP.NET container, and we'll copy our build.net content into place, and then we'll copy our build Vue content into place inside that www root folder. Now, we've named both of them, so here's our build.net container, and here's our build Vue container. The only other piece that we need to do here inside the .NET API is we also need to use default files and use static files. Now that will allow us to host content out of our www root folder where a typical API would not need to do that. We also have one more controller, a SPA controller, that basically will say, for all of the client-side routes that we might have, return the index.html page. That means that when we're navigating through our client-side routes, if we push refresh in our browser, we'll still get the correct pages. Okay, so let's take that for a spin. I've built these containers previously, and so let's run them. I'm going to say docker run. We'll map port 5000 into the container, and we'll run this one container, one domain instance. Okay, so it's running on port 5000. Let's fire up our app on port 5000. Our API is working just fine. Let's go to our front end. Ooh! As we loaded the page on port 5000, then when we went to go load the weather forecast, also on port 5000, we see that we were able to reach the API just fine. We weren't going across different domains here. The machine is all in one piece. Everything worked. We've got our temperatures. Now this worked, but, well, there's some downsides here. In development, we'll do a similar process as we did in all the other scenarios where we have our SPA using Webpack Dev Server to proxy off to our API. In production, we'll do it like this. We have one big container that hosts all the things. Now, yeah, technically in development, we could do the same thing, but our API is running a debug mechanism here, and our Webpack Dev Server is ensuring that we get hot module reloading. So putting them all in one place in development may not make sense. Now that does mean in the API, in development, it's never hosting static files. Yeah, that's fine. Okay, so we got to see how that worked, and it worked great. On the upside, we were able to deploy the entire thing. We didn't have to worry about cross-domain issues. We didn't have to worry about going between different pieces. But on the downside, we now have one big piece that we need to scale together. If we wanted to scale our front end and our back end separately, in this case we couldn't. They're all in one container. Well, when would I choose this? If I have a Netlify account, or I have an Azure Web App, I have something where I only have one piece. Maybe I'm hosting my monolith. This is a really elegant solution because I only have one hosted domain. I don't need to sprawl across many microservices in this case. I only have one account. If I don't have an orchestrator, if I don't have Kubernetes, then this can be a really elegant technique. Next up, let's look at two containers and two domains. Now in this case, the browser is going to reach through to www.example.com to get to the SPA, and the browser will reach through to api.example.com to get to the backend. They are two different containers running on two different domains. Now, because they're cross-domain, we need to do a bunch of jumping through hoops. As the browser starts doing an AJAX request, the browser will intercept the JavaScript experience and do an options request off to the API. What it's looking for is this cross-origin header, this access control allow origin. It gets back the list of domains that are allowed to do cross-origin requests, and it validates that its domain is in that list. If it's not, the browser will block the JavaScript request and it will just fail straight away. If it is, then the browser will continue with the original request, the get, put, post, or delete request, and it will complete as it expected. Now, to pull this off, the server does need to be able to specify what that core's domain list is, and the browser needs to reach into that other domain. That means that we have two additional pieces of configuration, one in each website. The SPA needs to know where the API is. The API needs to know where the SPA is. And in different environments, those will be different. So let's dig into this solution. Here in this solution, with two containers and two domains, we have a backend. Now here in our backend in startup.cs, we have to add all of the core's details. We need to know where the client API is. Now this will be different in different environments, but in this case, in our Docker file, we can inject that in as an environment variable. As our container starts up, we can do the work needed to be able to configure this. It's a little bit different on the front end. Here in our component, we have the weather forecast component. No longer can we just reach out to /API/weather forecast. Rather, we need the full domain. And so we need that base URL up to the API. Now, in the case of Vue, it needs vue_app to be able to bake these environment variables into place, because these environment variables don't run on the server, they run in the browser. So we have some .env files that when we run npm run build will get baked into place. And so now we'll have that full base URL so that we can make this request. Okay, let's spin down the previous container, docker rm-f, or docker container rm-f 6d49, and let's spin up this new container, two containers, two domains. Now I'm going to run the backend container on port 5000, and I'll run the front end container on port 80. But I'll proxy that in from port 3000 on my local machine. Now, the API needs to know that it's running on port 3000, not port 80. This may get complicated. Let's fire this up. Minikube 3000, and let's take a look at this app. Okay, so that worked. We've got our weather forecast. Now, as we spun up, this one hit localhost 3000, and we're able to load our SPA. That's great. When we came to do the API, we switched over to the other port, localhost 5000. Now, as we did that, we went and did a check to see if we were in the access control allow origin list, and in this case we are, and so that request went through. Now this is cool. This is an elegant solution for being able to do two containers on two domains. On the upside, if we need to scale these things separately, we now can. They're running in different containers. So maybe we need 5 copies of our backend API, but we only need 2 copies of our static web server. On the downside, there was a lot of work to get those CORS headers in place. And the CORS headers need to be baked into the front-end container, which means we can't just promote that front-end container between environments. It needs to have those baked into the static JavaScript that gets loaded on the page. Remember that the environment variables are not running here in this SPA server. The environment variables are running in the browser to know how to connect to the API. So we must bake them into the container, meaning that we're going to build different containers for each environment. If we're using core headers, We can't just promote variables across or promote containers across. When would we use this? When we have very different teams working on the front end and back end, and they can agree on a standard methodology. If that's the case, then this can be elegant because I have that great separation of concerns in my organization, so building that separation of concerns in our containers works out as well. Next up, let's look at 2 containers, 1 domain. Now in this technique, everything's going to run from a single website. We have example.com. As the browser reaches out for content, it's going to reach out for content for the spa on example.com and also for the backend content on example.com. Now this Kubernetes ingress controller understands the paths in our application. If it starts with /API, it will send it this way. If it doesn't, it will send it to the spa. This Kubernetes ingress controller is that mechanism, that router, that is able to direct some traffic here and some traffic here while listening to a single domain. In development, we'll still do the same Webpack dev server, but in production, we have this Kubernetes ingress controller to make this happen. Our browser reaches into the same site for both the spa and the API. In development, we'll still use our Webpack dev server. We won't use a Kubernetes ingress controller here, so the browser will reach out to the spa for everything, and the spa will forward on requests for a particular system. Now, why can't we do that mechanism here for 2 containers, 1 domain? Well, because in this case, our spa container is a static web server. It knows nothing about different routes. By comparison, our Kubernetes ingress controller does have some logic processing that is able to forward content either to our static web server for the spa content or to the API for dynamic content. So let's dig in and take a look at 2 containers, 1 domain. Let's first stop these 2 containers. Docker container rm-f 7bd1. Docker container rm-f 90517. Now in this case, in our 2 containers, 1 domain scenario, we have not only the Docker files. Here's our Docker file for our backend. It's exactly as we had before. No weird CORS headers. It knows nothing of the fact that it might be hosting on a single domain. Our Vue app is really simple as well. The Docker file is really straightforward. We have our 2 phases, and we're able to build what we need to. Similarly with our component knows nothing about the backend API. 2 containers, I'm still in the wrong spot. 2 containers, 1 domain. Our component still knows nothing about the backend API. It's just calling /API/weather forecast. Perfect. Here's the Docker file on the front end, no CORS header. Here's our Docker file on the back end, no CORS header. And our backend startup also doesn't need to host static files anymore. Perfect. The magic happens inside our Kubernetes YAML files. We'll have a deployment for our backend where we just say, hey, I'm going to host this image. I'll run it on this port. We'll have a similar service that will be able to round robin across all of the instances of this service. We'll have similar deployment and service for our front end. Now in this case, we chose to make 2 replicas of our front end, but only 1 replica of our back end. We can scale them separately. The magic is here in this Kubernetes ingress controller, where we say if the URL starts with /API, we'll go in this direction. Otherwise, we'll go in this direction to this service. Now, if we were running this in production, we would include a host header. We would also probably include TLS details. But in this case, on this example, we'll just do it straight away. I am disabling SSL redirect because we're running it locally. So let's start up this 1 container, 1 domain. In this case, I'm here inside the folder with the Kubernetes YAML files. And so kubectl apply-f k8s, I will apply the folder, which will apply all of the files within the folder. So we get our ingress, we get our deployment and service, kubectl get all. We see that all of those are running. Kubectl get ingress. Here's our ingress running. It's running on port 80. So let's head out to our cluster, port 80. And we'll load our ingress controller. Now this is cool. We loaded our home page, and our home page ran on just localhost :80. And then when we went to go get our weather forecast, that was also on localhost port 80. Our browser knows nothing about the fact that there's a Kubernetes ingress controller behind the scenes. But behind the scenes, we were able to do exactly that. We hit the Kubernetes ingress controller, and when it needed to go to the SPA, it grabbed the SPA for JavaScript files and HTML files, and when it had /API in the path, it went off to our API server. That is cool. When would we use 2 containers, 1 domain? Well, 2 containers, 1 domain allowed us to scale them separately. We have 2 copies of our front end and only 1 copy of our back end. We don't have any complexity around CORS headers. We don't have any environment variables that need to change between environments, requiring us to rebuild our containers. On the downside, we do need Kubernetes. We need that orchestrator. So when would we use this? When we have a Kubernetes orchestrator in play. If we have a Kubernetes orchestrator, maybe we have lots of microservices that we need to host, then we can do this in a really elegant way behind a Kubernetes ingress controller. If we don't have an ingress controller, we may need to find a different solution. As we look in here, we can also look at server-rendered SPAs, and this may complicate our concern as well. If I'm doing a SPA that is pre-rendered on the server, I really need to have, well, server processing for my SPA. So I'll probably need a mechanism that is able to compute that content on the server. We can't host our static content in Nginx anymore. We need Node there. So this will work really well if we have a Node-based server, but we can do it in other languages as well. Next, Nuxt, and Universal work really well for React, Vue, and Angular and being able to host server-rendered content. When would I use server-rendered content? When I need to be able to do search engine optimization of content. If I have an unauthenticated page and I need to rank well, Google may be able to crawl my SPA, but handing it the right answer straight away given the correct URL will definitely make Google's job easier, which will likely rank me higher. On the downside, I probably need JavaScript on my server, which probably means I'm going to run a Node server, not a .NET or a Java or a Python server. Server-rendered SPA. Choose this when you need search engine optimization, when the majority of your site might be unauthenticated. For authenticated pages, server-rendered SPAs may lose some of that benefit. So we looked at these mechanisms. 2 containers, 1 container, 2 domains, 1 domain. When would I choose each one? Well, it depends. It depends a lot on the needs of your organization, the size of your project, whether you prefer monolithic or microservice-based architecture, how many services you have. Let's take a look at them. If you're going to run 1 container on a single domain, this is usually best when you have a monolith, when you have a single hosting account. You don't need to create lots of different hosting accounts to host all the pieces. They all just work in one place. How do we solve this? We put our SPA content in our public folder of our server. By comparison, 2 containers, 2 domains. We can use this when we have CORS headers and environment variables. This is perfect when we have really crisp separation between our front-end and back-end development teams. By comparison, 2 containers, 1 domain. From the surface, this is really simple. The browser just connects to the same domain and gets the content that we need. We can scale each piece separately because both the front end and the back end containers are running separately. If we have Kubernetes, this is an elegant solution. This is great if we're hosting lots of microservices. Our Kubernetes ingress controller could be configured to have lots of paths, pointing to lots of different containers. Choose 2 containers, 1 domain if you have lots of microservices and Kubernetes. This has been a lot of fun being able to show you how to build .NET and Node services, SPA, and APIs hosted in one or many containers. Grab me on Twitter if you're watching this on video at rob_rich. And if you're watching this live at the conference, I'll see you in the Q&A that the conference has designated. Thanks for joining us.